potential dream. Visualize just what we mean. Innovation shaping our fate. Together we celebrate. From data to display, community lights the way. Liquid galaxy, we see it all. Technological marvels standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive.
Hi, my name is Darpan Bhaviskar, and this is the submission for the Gemini Summer of Code by Liquid Galaxy. And here are my deliverables. Uh, so, this first repository is Flutter Starter Kit, which contains the .agent folder, which consists of various skills needed to create an app using Flutter. And this starter kit is only for Flutter, based on Flutter. So, this is the detailed technical documentation of it. So without any delay, let's deep dive into this .agent folder. As you can see, I have structured the agent folder in such a way that it will be easy for the agent to locate and retrieve the needed markdowns for a particular operation. So as you can see, the first one is foundation, then other one is patterns, features, guides, relevant templates, then roles, then workflows, some errors which are, handled by the troubleshooting folder. There are domains, foundations, and various different kind of folders in which I have listed, relevant markdowns. And at the end, as you can see here, there is a quick reference markdown, which is kind of a cheat sheet for the agent. So what it does, so when an operation is prompted to the agent, it goes to this quick reference to get it is just like a cheat sheet. It gives a quick reference to the agent where to go, what is needed, where the thing is located or not. The next one is readme, then restructuring complete and structure overview. This kind and index.md, which is the main one. So I have created this index.md. So as you can see, this agent dot folder is very overwhelmed with information. So the agent might get confused while using this information. So I have created this index.md. So what it does, it reorganizes the folder and it indexes, it indexes the hierarchy in such a way that it will, the navigation of the agent will be improved here. So as you can see, I have I have just refined this index.md here. Then as you can see here, in the foundations folder, you can find the architecture, MD, Golden's rules.markdown, etc. Uh, the main one here is the pattern one. As you can see, I have initiated the KML patterns, service layer, SSH patterns, and state managements. I have created this markdowns, uh, you know, referring to the Liquid Galaxy projects in its GitHub. I have used that training data and I have listed it into this markdowns. As you can see, these are all the markdowns present here. So, uh, and this fourth folder contains some best practices that developers perform. This all markdowns I have created or referred from the training data from the Liquid Galaxy projects. This one is for best practices. This is for the common mistakes. This one and this one is for KML generation and SSH integration. These are some very hot topics where many developers might get stuck. Uh, then there are, many folders here. The one is this one, the eighth one, troubleshooting. This troubleshooting contains, all the all the errors which are faced by many developers here, and their solutions, what not to do and what to do in this case is listed in this markdowns here. As you can see, let's go into this KML errors. Here are different kind of common mistakes, and the solution for those mistakes are listed in this markdown, which will help the agent to do its work relentlessly. And yes, this is all about the agent folder. The next one is the LG starter kit result repository. This is the second repository in which I have my agent folder, and I have done and the result and the experimentation which I did using this agent folder. So as you can see, this is the agent folder, and I have created this LG controller app via this agent folder via using the Google Antigravity. So this is the, the project structure, and the project structure is it is well refined, and I will give a quick demo of this app, and then I will show you an live demo that how the Google Anti-Gravity agent creates an Flutter app using the the agent folder which I have created. So let's move on to that thing. Mhm. So this is my this is my this is the same repository in my local. This is the local repo on my PC, and as you can see here, this is the LG controller app which I have booted here. I have booted on the emulator. So as you can see, I have connected it to the Galaxy Rix, and it has many functionalities. The one is shut down, reboot, relaunch, send and clear logos. Then there is fly to New York, sending a 3D pyramid. Then I have used an external API of ISS, the International Space Station, which dynamically tracks the ISS. The another one is Smart Tours, KML agent. In this KML agent, I have used the Gemini API, which uses the natural language from the user and converts it into KML, which can be either then used for doing tours or placing place marks or doing an image overlay, etc. This one is for location lookups. This one is for weather overlay. I have used an API here, and this is the earthquake tracker, which in which I have also used API here. And this last one is the clear KML option. So uh, let's do a quick demo of this thing. So when I will send a logo will appear, on the left screen here. You can see the logo is appearing here. I have not put a file here, a PNG file here, but yeah, the logo is appearing here. I have cleared the logo right now. Now I will fly to New York. So the flying feature is working fine in this case. As you can see, this is the New York location. Now let's send a 3D pyramid to New York. So I have opened this app demo, and let's select New York, and I can set the latitude and the longitude, but as I have selected New York, it is preset. I can change the altitude and the the base size of the pyramid. Let's choose the color yellow, and let's send the pyramid. And as you can see, this pyramids get appeared here. This is a 3D KML pyramid. So yeah, it is working fine. Now I will clear the KML here. After that, let's move on to this one. the ISS tracker, uh, I'll start tracking. So what it does, we use the ISS API here, and it constantly sends the latitude and the longitude of the ISS where it is. And after every 5 seconds, the KML gets updated, and you can see a dynamic tour of the ISS here. So as you can see, now there is a 5 second wait in this, and then it will again update the KML, and it will send it to the master.kml on the Liquid Galaxy machine. So it is working like this. So let's stop this thing and let's move on to the next feature. The next feature is smart tours. So what it does, I'll just select a new tour, and let's say I will name it ABC, and let's add some description, whatever it is. Then maybe I will select maybe this location here, and I will save it. And this KML will get saved in on the app, and then I will play this. I can fly to this location here. So we are using, the inbuilt module of Flutter map in this case, in which the user can, just fly to whatever location on the map. So I can just fly to any place by just pointing out on the map. So this is working perfectly fine. And you can edit as well here. You can delete the KML and you can export the KML onto your on your emulator or phone. Let's move on to the next feature. The next feature is the KML agent, which is the very interesting feature in which when a user like queries with a natural language, it generates the required KML as the output and gives us the users the ability to play or play the KML onto the master rig of the Liquid Galaxy. So let's give it a custom prompt: create a tour to New York. Wait 4 seconds and then fly to Berlin. Okay, so I'm generating the camel right now, and as you can see here in this starter kit, I have created a Flask server which I have hosted locally, and it uses the Python script, the KML Python agent script, which contains it is the script. It has, you know, prompt here, which is used when the query is, query by the user gets, entered in this kml.agent py via the Flask server. It generates the output, and then it then we send a get request, and the result is returned. So as you can see here, the the KML is generated. There are multiple features: send to LG, play tour, copy, clear. Let's send it to LG. After sending it, let's play it. As you can see, it is playing. We are, first of all, uh, we are flying to the location New York. There is a halt of 4 seconds. Then we are flying to the next location, which is Berlin. So, so this is a very, very interesting feature in which any beginner person, any amateur person can just give a query in natural language to generate a KML. We can also generate KML for place marks, for some 3D KMLs like pyramid. I can just generate I'll just say create a 3D pyramid KML in Berlin. I will just generate the KML. And in this thing, we are using the Gemini API, which is listed in the rules of this contest, in which we have to use Google Antigravity and Gemini. So as you as you know that it will take a little bit time to generate. So the the whole architecture is that uh, we are sending prompt. The prompt is getting to the kml.agent py, this one, via the Flask server which I have initiated on the local host. It processes, it makes the output, and the output gets returned in this emulator. So as you can see, the KML is generated. This is the KML, and I'll send it to LG. After sending it to LG, I'll just see in Berlin. I am currently in Berlin right now, and as you can see, this is the pyramid here. We can generate numerous kinds of KML using this thing. So I'll just clear it. For now, I'll just clear the KML, and as you can see, the KML is cleared right now. Now let's move on to the next feature which I have generated via this .agent folder using the anti-gravity IDE, which is the location lookup. This is I have used an API here. Like, let's say I have to fly to Big Ben, so I'll just search for the Big Ben location. This API gives us the result, the coordinates, the latitudes and the longitudes of that place. I'll just select it and I'll just fly to that location. So a flying tour KML is sent to the master rig on the onto this liquid galaxy, and as you can see, we are currently somewhere as you can see, a Big Ben is located here, and we can also fly to different kind of different locations. Let's say we have to fly to the Statue of Liberty. Let's fly there. So this is a very good feature which can be used to for lookup of location. As you can see, we are currently in New York, and this is the Statue of Liberty here. So this feature is also working fine. Let's move on to the next feature, the weather overlay, in which you have to just type the name of the city and you'll get the weather. You'll get the the weather information of it, and this is also using a weather API. So this app has some multi API functionalities here. As you can see, this is the get weather functionality. It's a simple functionalities. I've just implemented uh, multiple APIs features in this app. I have created this app using the .agent folder, and this one is the earthquake tracker feature. This is also, this feature also uses a API here. So let's say I have selected the magnitude, let's say minor, and I'll just show this on the map. So about 80 earthquakes are sent to the liquid galaxy. And if I'll just zoom out on this globe, I can see place marks onto this globe at different positions. As you can see, this place mark is here in the ocean. This shows the information of the of the earthquake with the minor magnitude. You can as well as see this here, this place mark, and you can see numerous place marks here in this region. There are different kinds of place marks, and now I will just clear the KML. So these were different kind of functionalities which uh, I have integrated into this one app, LG controller, and I have made this app using the .agent folder, using the all the training datas, harvesting all the markdowns from the .agent folder here, and using this Google anti-gravity ID.
Hi, my name is Shukla. This is my submission for Gemini Summer of Code, in which we have to build a Flutter starter kit. So before I explain you the structure of the Flutter kit, I'm first showing the application. So this is the home page. It contains only basic task to level features. Uh, while building this application or kit, my goal is to give a strong foundation. So we can easily build a Flutter controller on this starter kit. So it has clean KML, show logo, and clean logo buttons, and a view map page. So let me first go to the settings. This is the settings page where we can enter details and connect to it. So one thing also, if we try to connect, click on any button without connecting, it will show us a snack bar not connected to Liquid Galaxy. If I go to the map page and try to click it here also, it will also show the same thing. So the application is built in a way that until and unless you are not connected to Liquid Galaxy, it will not work. Uh, so it will protect us from unnecessary SSH calls. The application will only work when we are connected to Liquid Galaxy. Basically the features. Now when I connect to it, uh, now when I click on it, here you can see the command is executed and the Google Earth is moving. So basically, wherever I click on this map, a KML file is sent to the location, Google Earth. Now there is a requirement to use an external API key. So for which I use Google Place API, which help me to suggest locations. So what does I mean that? Let me show you. If I type P here, it may show location name starting with letter P. When I click on that, and it will send KMS to the Google Earth. Now let me explain you the structure one by one. So first, let's start with dependency. Flutter revert pod is used for state management. Then Dart SSH2 is used for SSH connection. Flutter secure storage for storing credential like IP username in local storage. Flutter.env for storing loading environment variable. Shared preferences is used for creating key value pairs. This package helps us, like when I close the app and open it again and go to the settings page, the IP username password which I enter will remain on the screen, will not be lost. Now then is Google Maps Flutter, which allow us to show the map. Then DO for networking related things. Now permission handler package allow us to request permission like location, camera access, etc. in an Android and iOS device, and logger for printing beautiful logs. And in development dependencies, we have Flutter test for writing unit and widget test, integration test for writing integration test, and Mockito and build runner for creating fake dependency to make our unit and widget test independent of any external factor like internet. So I have created this Flutter kit on the clean architecture, which promotes separation of concerns. Basically, it means each layer is independent of each other and focused on only one purpose. So the the UI layer is focused on the state management and displaying the widgets. The domain is focused on entities and business use cases. The data is focused on API related things, SSH calls, and data storage. Core contains the injection container Dart file, which is used to inject dependency. Now let me explain you the folder briefly. First is going to the domain layer. This is the layer. If other layers get affected, this layer should not be changed. And if this layer is changed, then the whole data layer and the UI layer will be affected. Now it contains the entities, which is the data that our business requires. So we have connection entities, fly to entity, and orbit entity, and so many. Then there is repository, which contain the abstract methods or and tells what are the operations we can perform. Now then there is place repository. Similarly, uh, permissions and SSH, these all are abstract methods. It is not implemented here. Now then there is use cases. This contains the actual business logic, like fly to location use case, which when we call this method inside the fly to use case, then we are going to fly to a location. So currently when I click on it, LG repository, it move into the LG repository, and it contains the abstract methods. It does not have any implementation. So also the use cases come under the high level logic, and the implementation of LG repository is is in the data layer. Here you can say all the logics are written here. This is come under the low level logic. Now the high level logic like use cases should not depend on the uh, low level logic. So currently our use cases depend on these abstract methods, and these abstract methods are implemented by the LG repositories. Now here come the injection container. When the use cases ask for like LG repository, since here we are using it, so it will ask for it. So instead of giving it LG repository, we are going to give it LG repository implementation. So and it is look like LG repository. Here you can see it returns LG repository. So the use case doesn't know whether it is getting the abstract method LG repository or the implemented one. So this separates the high level logic and the low level logic. Now then there is data layer, which contains the data sources. It contains the logic for SSH calls, API calls, data storage, and permission implementation. Now then there is models. The difference between entities and the models are entity is the actual logic data that our business needs, and we want that if we change some logic, uh, the entity should not be affected. Models are representation of entity in the data layer. Like if we do not have model and we calling an API, so there are some parameters like latitude and longitude. If they get changed by the Google server or some other server, so we have to update the domain layer, which we do not want. So fly to models help us to do this for us. If any of the here this thing ever get changed in the response, so we only have to update the models in the data layer, which protects our domain to get unaffected. Now let me show you flow how this happens. Well, let me go to this session. Here you can see this is the settings page. Inside this is a elevated button. Uh, this connect to rig. Now when I tap on that, here you can see when I click on that, it called the notifier.connect. Notifier is the connection notifier. Yeah, here you can and connection notifier. So the connection provider provide the connection notifier. It is a state notifier provider which help us to update the state, and it contains the connection entity as the state. These are the dependency which it uses, like connect to LG and use case. And the connection notifier contains the connect method. When we call this, it calls connect to LG, and here you can see uh, uh, it is a variable which contains connect to LG use cases. So when I call this connect to LG call dot call method, actually we are going to this connect to LG use cases and call the connect method repository dot connect. Now here come the dependency injector. Let me instead of providing the here you can see this LG provider, which going to inject the LG repository implementation in the uh, in connect to LG, and this is overall the flow of the app, how this work. Uh, when we go to the LG implementation, when it call connect here, it will call SSH service dot connect, and we are able to establish this connection. So this is the overall flow of the how it works. Now let me close you. I explained the structure of the Flutter kit, how the data flows. Uh, now let me explain you the uh, agents folder. Uh, for this, I'm moving to another folder, LG implementation. This is the same thing, but I have cloned it so we can work on it alongside. So I'm going to use the Gemini 3 Pro model as per the requirement. We have to use Gemini model, so I'm going to use it. Hey, I want to create a LG Flutter controller. This is the agent folder. Here there are 6 skills files, and there is 2 workflows files, and there is one starter kit context. This is specially designed for the agent to reference this file. Now it contains all the overview of our entire project, all the methods that are used, the folder structure, and what principle we follow, how to create if you want to add a new feature, how to do that. So the flow, if you want to add a new feature, like we first add entity, then abstract method, then use cases, then we implement the uh, that abstract methods we created, then provider, create a provider, and then finally UI. So then here is written like we create an entity, repository, use case, repository implementation, provider, and then a UI. And also we have added a manipulation for detecting manipulation, and the packages we use after completing the init phase. It make a session state MD file, which is used to help agent to track on which stage it is. Now this is how we are going to how the agent is going to test when it create features, like to generating mocks, they run this command, and to run all test cases, run this for specific cases, they run flutter test and then path of the file. Now these are the methods, and also about files. For camera position, to write in query.txt file, it tells the agent to write, for moving camera position, use query.txt file, and for synchronizing among all screens, use master KML. Also telling the agent that query.txt file do not require any refresh, and the rest of the KML file require a refresh. Now this is the entire overview of our project. Telling the agent that our project follow the solid principles, clean architectures, and SSH golden rule, that never put SSH calls in build method, because when we put SSH call in build method, it build 60 times a second. So if we put SSH call there, the UI might freeze, because an SSH call takes a half a second to create a connection. And in 60 second, if we put it there, it is going to call 60 times a second. And this is overall overview of the file. Now let me read this. Yeah. So it is asking us the project name and target platform. and the feature idea. So the target platform is phone, and currently I do not have any idea. Can you suggest some idea on which we can work? Now let me show you the init file. So init file is the initialization phase. Here, this is the first phase where agent start. Now, the first thing is that is to read the starter kit context, because it gives the complete overview how the fold how everything is created. Then it asks for the project name and target platform and first feature. You have seen that it here. It asks that. Now it teaches some fundamentals about the LG, like for moving camera position, uh, uh, which file require might this tell you in LG fundamentals, and ask one questions after explaining it. Then yeah, after completing it, the init phase, it create a session empty and move the to the brainstormer phrase. It contains some manipulation detection techniques. No, the init phase doesn't contain it. Now I have also tell it to use some emojis for a better look. So the project is suggested, since you are starting a fresh on a phone. Here are three beginner ideas that are perfect for learning. I'm a curated guide for the seven wonders of the world. Tap a Taj Mahal, LG flies there, orbit around it, and shows an info card HTML around the right screen. Camera control, managing content on different screen, master slave. Hmm, where is the world? The phone asks, where is the Eiffel Tower? You guess. If correct, the LG zoom to into the Paris. Mhm. One idea which I might think is good is the World Wonders tour. And but can you suggest more ideas? And what you are going to display on the HTML balloons? Now after that, we have brainstormer phase. Uh, uh, Here with the agent and user will work together to discuss what they are building. And after the it gives us some option how to approach a problem. And then after brainstorming, it asks move this to move us to the engineering check, where it asks questions, and checking the also that proposed idea is logically relevant or not. Now architecture overview. Also at the each phase, the starter kit is required to read it. Then session state for tracking the, and after the brainstorming phase, it design create a design MD. So here also that it asks when the brainstorming phase is completed, it asks for whether the user is satisfied or not, or does it want to modify any changes, or move to the engineering check for question answering. I think an HTML web page, pop right on the Google Earth. So, uh, so, so let me select a project. Um, I like the earthquake monitor to visualize the earthquake. I think this is will be better. So I want to visualize earth. Uh, I want to choose the live earthquake monitor. Mm. Now after that brainstormer, we go to the plan writer phase. After the engineering check is complete. So let me show you the skeptical mentor MD file. So you are expecting over here. So the first step here is that it read again the agent starter the context, ask verification questions, and also here manipulation detection is mentioned. Like here you can see that if the student is passed, then it will move to the plan writer. And let me read this. Awesome, live earthquake monitor. This is going to be super cool. Data into KML. Google Earth watches file. This is coding build and flutter build. So here you can see the SSH thing which I told you. It mentioned that and to you show a red circle on the map for a new earthquake. Do you need to refresh? And yes, we need to send a refresh command. So to tell Google Earth that data is updated, read it. Now I'm going to see you the plan writer. So these are the things which is mandatory to do the for in each phase. Uh, I added the .agent context folder because when I'm testing it, it is forgetting about the context file, not working properly. So I added in the each file some pre-request checks if, whether the engineering check is completed or not. If it is missing, and then it will redirect the data. Then it will write the plan, and after that, uh, and we move to the execution phase with context. Now you tapped into the core difference query. The fast lane for movement, but everything visual needs to be there. You nailed it. Let's save your earthquake monitor. All quick shows everything hundreds of dots. Might be cluttered but impressive data. Only magnitude cleaner. Focus on real event. Visuals simple circle. Red dots. Size magnitude. Traffic light. Yellow. Red. More informative at glance. Uh, the interaction. The LG camera fly directly to the quick location. It is. Show info. The LG stays put, but balloon pop up on the right side screen with details. Map. Phone list. A scrolling list of quakes. And a Google map on your phone. Screen showing the dots. Hmm. So I think it is better to show only few, the necessary ones. So I'm going to choose for B. Then uh, I'm confused about this part. I will ask it more. And for third part, I want to both to move to that location and as well as on the right screen. So the info, and I want a list view in the fourth part. Mm, and can you clarify more about the second part? Oh, Uh, this is executor phase, which is after plan writer is completed and two verification checks is completed. Then will move to the execution phase. Here it write the code following the principles we made, and at the end it run and analyze whether our file app is working or not, if any of the test cases created is failed or not. So this about the how the earthquake dot look on the globe. Every earthquake is a red circle. The size changes. Small quake is tiny dot, big quake is a huge circle. Traffic light, just the color changes based on danger. Small, just a rumble. Look out, and so you instantly know here there is a big red one in Japan without checking the size. More like a warning system. Very easy to read. A bit more colorful. Both, and now as engineer, you big choice to make about how we fetch the data. App load data once when you open it to get new kicks. You go to refresh. Simpler code and easier to understand flow. Not live. App auto update every 60 seconds in the background. New kicks just pop. Truly feels monitoring station hands free. I think I am going for the A option for the engine. This there should be a refresh button. On clicking that we can able to get the data. Uh, for the engineering part, I'm going to choose the option A. There should be a button. By clicking on it, we should get the quicks. New quicks. Now for the visualization, I have spelled out. Are we going to visualize every earthquake or a single earthquake? Doubt. You have get the data when you want it. No surprise there. The answer is both, but at different times. But at a different times. Yeah, when you first open the app or hit refresh, the entire globe hit with many little dot pins, maybe 20, 30 of them scattered across the world. This gives you the big picture. You instantly see where the Earth is active right now. Drill down. When you tap quick in Tokyo, camera flies smoothly to Tokyo. A balloon pop up with the details. And because before we log this here, how we build it is using the starter kit. We will use USGB API key needed. Satisfaction check. Yes, love it. Uh, I have still question if when we click on a earthquake, we will move to that location and orbit around it. Then other earthquakes are going to be removed from the screen. When you tap a quake in Tokyo, the camera fly there, you see the big red dot for Tokyo. But in the background, you can still see faint dot for other quake nearby. It shows patterns. Earthquakes often happen in clusters. Seeing the neighbors help you understand why this one happened. We send one big camel by the will all dot. We just remove the camera. When you tap Tokyo proof, all other dots vanish and only Tokyo exists. Uh, can you give provide the how the page will look in the controller? And I think it would be better to be single quakes at a time, and a button also to display multiple quakes also. Now I'm going to tell you what happen after the execution failed. It will have a verification check where we will going to debug whether our app is working or not. Uh, we can show the errors and the agent will fix it for us. After the verification is done, the app is completely working fine. Then we will move to a complete code review where it will run all test cases one time and analyze the Flutter app using Flutter analyze command. And after that, we move to the quiz section. But at the top of the list, clear everything, then put action. A big white button at the top of the list show global activity. Clears everything, then puts all dots on the globe. Camera flies to a zoomed out view of the world. A list scrollable recent colored circle with magnitude in red, location and time, and subtle tapping on a global view puts a single pin on that location. Fly the edge to it and orbits. Opens the info balloon. Uh, Currently, I am not want the orbit feature. Just a display. Move to that location and I am able to see the earthquake area in red or green or orange based on the magnitude. And there is marker on which we click. We will able to see info card on the right screen. And you can also add a filter on the base of the magnitude we want to watch. Also a date range picker to get the date of data we want to visualize. Now I'm going to show the code review part reviewer, which does the code review. Read the starter kit. It basically check whether the clean architecture are followed or not. Run the test cases. Any dry principle violated, solid principle violated. Uh, Visual traffic light system on the globe. Tap a quick fly to it, no orbit. Shows detail in HTML1 on the right side. Shows only 5 plus magnitude. Data date range picker shows quick from Jan 1st to okay. Before we start engineering, check how the code will look. Entity get quicks call repository started and fly to use case show quick info data layer. I think these are the abstract method and we will build the API URL dynamically UI layer and I think it's look okay. I'm going to proceed to the skeptical mentor. Yes. Let me try to skip it to check whether the uh, we are able to skip it or not. Can we go to coding part? Let me see the question. We decided to have a quick to move the. Why are we splitting these into two separate? Why do not write one big fetch and fly function right inside the? uh, Think of just write one big fetch and fly function. The right inside. Um, but here you can see that it able to check whether we are not we are keeping this. So it mentioned to answer the question. Why split get quicks and fly to into what happens if you want to change the area. So we decided to have a get quicks use case and a fly to use case. Why we are splitting into two separate classes? Why are not just write one big fetch fly function right widget uh, traffic you want to show green orange red dots on the globe, which file path on the rig should be right camel to we and will this need a force effect the fly to action when the user tab we want to move the camera starter key which specific file in the method specific method in the LG repository are you going to use for it? Does this method use the fast lane or the content lane? So I'm going to answer it one by one. uh, if we separate these two in separate classes because in solid principle it is mentioned to use a class have only one responsibilities and we do not write fetch and fly because it makes the our data layer with the UI. Mm. For the second question, we are going to write in master KML. Yes, we are going to use the refresh method. For the third question, fly to method in the LG repository is going to used. Uh, for the part currently, I do not know the answer. Can you provide the explanation for the part which I do not know? Uh, you are correctly identified that we need to separate classes and use force fly to your question. The answer is send query, which write this is the fast lane. Google Earth watches this file constantly. So as soon as we write the coordinate, the camera move instantly, no refresh needed. So uh, now I'm going to proceed to the next step. I think I have given one wrong question, one wrong answer for one of the question. Lie to. I think for this part. So now it is moving to the execution phase. Hello, hello sir. Now I'm going to give you a quick overview. After the execution phase, the reason for that is that the time constraint and the verification phase took some time, and the agents take some time to fix the errors which came. I'm going to show you the chats one by one. This chat is before the execution phase. Now it after the execution is completed, it asks me to verify it, and after the I run the flutter run command, and the first error came is that the agent use equitable package, but it is not installed. So after that, the second error which comes is that here you can see this is filter of magnitude. When I increase this, the SSH connection is dropping. So this is the second error. The third is that some error in snack bar is present. So it fixed that, and after that, it removed the snack bar, and I told you to add that. And now after that, it told him to change the color to light red. Now after that, the here you can see this 30 days is not working. When I clicking on it, it is not working. So I told him to fix that, and after that, the feature we want to add is added properly and working properly. Now it asks me to add a new feature or enhance existing feature, or focus on testing feature, continuous integration. If we want to add a new feature, we will go back to the brainstorm phase and again do this everything again. And after that, final code review is done, and then it asks me question, what is the difference, why earthquake model is used. So so that the all the cleaning of response related thing is handled by the model, not by the earthquake entity, which is the part of the domain layer. And the second question is that uh, whether the Google Earth is showing changes immediately. So the answer is no. We need to call the force method, and also ask me about query.txt. So it Google Earth continuously watches that. So we do not have to update it or call the force method. Now it asks me question related to earthquake notifier. Why we now use set state? So set state create a problem called prop dealing. Uh, instead of using the set state, we use revert pod, which build outside the widget tray. So state can be easily accessed from there. Also, if we write fetching logic in the earthquake page, we violate the clean architecture. The UI should not deal with any calculation logic. Now it asks me why did we use the repository pattern instead of just making the API call directly inside the earthquake. So the earthquake come under the high level language logic, and the implementation come in the low level logic. And they both should be independent of each other. Uh, now this is the final question, I think. This is which file would definitely need to change. Like it is asking me to which if we update the API, which layer is going to change. The answer is data layer. Now after this, I told him to update the README, and after that I asked him to create a Git repository and push this code to the GitHub. Now I'm going to demonstrate the app quickly. So this is the home page. We know that much. And here is a new page is added called earthquake page, and here we can filter out the earthquake on based on the magnitude we want. For low earthquake, it will mark a green pointer. Now if I increase the so we have yellow one for medium range earthquake, and for red one for high uh, high magnitude earthquake. And this is the info card telling the magnitude, date, and time, and depth. So let me talk some strength and problem which I occurred during this phase. The first problem is occurred like when after the planning, it is mentioned in the file that to include ask some questions. So it skipped that. The second problem is a small problem. The agent follow the step-by-step process that is mentioned in the agent skill agent. uh, and from init to the code review and quiz it properly, but it did not update the session state, which I told him to add update it later. So it fixed that, and not a very big issue. And I think that is these two problems were came. The strength is that it properly follow the structure. It created the design we want, a pointer fetching the data from the API, and showing the info card in the right screen. So this is the final part. Thank you very much.
To a world you can see through panoramic screens, living in the grand spatial dream. Visualize just what we mean. Innovation shaping our fate. Together we celebrate. From data to display, community lights the way. Liquid galaxy, we see it all. Technological marvel standing tall.